Hello students, there are some very concrete concepts for today. This is based upon what you have been asking. So I thought I should make a video to clear all these concepts. So see, the concept number one is this is the calculation of binding energy. So see, how do you calculate it? Suppose there is an atom X, A, Z. X is the element, A is its atomic mass, and Z is the atomic number. So that means in this atom, there are Z protons. So the theoretical mass of the nucleus is equal to ZMP Z of the mass of the proton plus A minus Z will be the number of neutrons. So A minus Z into Mn, mass of the neutron, this is the theoretical mass of the nucleus, right? Now see, the actual mass of atom X will be given. This calculation, the mass, actual mass of the atom mx will be given to you. So this mass x of the atom includes the mass of the electrons also. This includes the mass of the electrons, and if we don't ignore the mass of the electrons, then the actual mass of the nucleus equals to mx minus zm. What you have subtracted, the mass of the total number of electrons in it has been subtracted, so that becomes the actual mass of the nucleus. This becomes the actual mass of the nucleus. Is this clear? Now see. So just a minute. So you'll see now the mass defect. Mass defect becomes ZMP plus A minus Z Mn. When you calculate this, all these masses will be given in grams, mass of the proton, mass of the neutrons. Masses will be given in the grams, or it will be given in the AMUs. So when you calculate this, you'll find that this is slightly more than the mass of the actual mass of the nucleus minus mass of the nucleus, that is what? Mx minus Zm. So this is the mass defect delta M. This is what? Mass defect delta M. This can also be calculated as ZMP. This minus will become plus. So ZMP plus ZME, that will become what? ZMH, mass of the hydrogen atom, plus A minus Z into Mn minus Mx. So now see in what way you will calculate. It all depends upon what parameters have been given to you. Suppose they are giving you the mass of the hydrogen atom in the question. Well, you cannot remember all these masses. They are in AMUs up to 3 or 4 places of the decimal. So you cannot remember this. All this data is always given in the question. So if they have given you the mass of the hydrogen atom, in place of giving you the mass of the proton, then that means this way of calculation has to be adopted. But suppose they have given you the mass of the proton and mass of the electron is not given in the question, that means here mass of the electron need not to be subtracted. Right? So it depends upon how the data has been given is the delta M, the mass defect. And one parameter is the packing fraction. This is the delta M divided by atomic mass A. That is, packing fraction is the mass defect per nucleon. This is the mass defect per nucleon. So this is also very important parameter for the stability of the nucleus. And binding energy is equal to delta M into, now it depends upon if this mass is in grams, convert it into kg into c square, or delta M into, if it is in AMU, then 931.5 mega electron volt is a binding energy. So binding energy is the energy that is emitted from the nucleus, that is liberated from the nucleus when the nucleus is formed. So this becomes the negative energy of the nucleus, which binds the nucleons together. That means if you want to make the nucleons free from the mutual interaction, you need to supply this much amount of energy to the nucleus. So there's a concept of binding energy. So hope you understood. First of all, you'll calculate what the theoretical mass of the nucleus. Then you calculate the, after calculating theoretical mass, you calculate the actual mass, which is given there. It is given there mass of the atom. But if you want to calculate the actual mass of the nucleus, then JEE will have to be subtracted from it. And there's a way you calculate it, right? Then see the next concept is, this is about the, now see, the concept number 2. This is related to the calculation of energy or mass in a nuclear reaction. Suppose the question is like you have an atom XAZ, and what they are given that this is splits into two elements, Y plus say, this is splits into two elements. One is P and Q. This is splits into two elements P and Q. Now we're giving you the mass of P, and P is known. Mass of the Q is also known. And momentum of one of the particles is known. Its momentum P is known. And they're asking you to calculate mass of X. What will be the mass of X? This to be calculated. And it is known that initially X was at rest. Initially, its momentum is 0. This is an important concept. So you see the calculations I'll be doing through this, not only this question will be done, rather some other questions in which the same calculation will be involved and will be a part of the step which I'm taking. Right? So see, because mass of the momentum of one of the element P is known, total momentum initially was 0. So the final momentum should also be 0. It means P and Q will be moving in the opposite direction with the equal momentum. So you see the energy of P will be equal to P square upon twice of mass of the P. Is that clear? MP does not mean mass of the proton here. MP is the mass of the element P. This is the kinetic energy of the element P. And kinetic energy of the element Q will be equal to P square, because momentum will be same, twice of mass of the Q. So the total energy of the reaction is what? It is P square upon twice of MP plus P square upon twice of MQ. And all these things are known to you. The momentum is known, mass of the proton is known, mass of the P element is known, mass of the Q element is known. So is the total energy. Is that clear? This energy will be converted into the mass. So depending upon that, what is the unit of this energy, what is the momentum, unit of momentum, etc. Suppose this is in NK system. You calculated this in NKS system. So this energy upon C square is the equivalent mass. That means in the reaction, this much of mass would have been lost. This much of mass would have been converted into the energy because this is the energy that has been generated. So this much mass has been converted into the energy plus mass of P plus mass of Q will be the mass of X. This was the mass of X out of which this much mass was converted into the energy. So mass of the X will be this much. So there's a calculation of energy in the nuclear reaction, how you calculate it and how do you relate it to the momentum and to the mass. Now see, one concept is related to the, this concept is related to the binding energy curve and calculation of energy in fission and fusion reaction. You see, this is the graph binding energy per nucleon, binding energy per nucleon, binding energy per nucleon versus atomic mass E. So the nature of this graph, is like this. See, initially the binding energy per nucleon, as the atomic mass increases, it increases. It remains almost constant for some time. The maximum value of binding energy per nucleon is for the iron. It is around 2. It's around 2.5 or 2.6 mega electron volt. I'm just forgetting. So the binding energy for binding energy per nucleon for the iron is maximum. It remains almost constant for some atomic masses, and then it starts decreasing. So the concept of fusion reaction is what? The two elements of smaller atomic masses, E1 and E2, whose binding energy per nucleons were E1 and E2. They combine to form a bigger element. They combine to form a bigger element. Now, atomic mass of this element will be, this will be E1 plus E2. As you know that in a nuclear reaction, the number of nucleons remains constant. Generally, what happens in a nuclear reaction is a neutron gets converted to proton or proton gets converted to the neutron, but the total number of nucleons, that is number of proton plus number of neutron plus number of proton, remains constant. So initially the number of nucleons was A1 for one element, for the other it was A2, and binding energy per nucleon was E1 and E2 respectively. Now the element that is formed by the fusion of these two smaller elements is having atomic mass E1 plus E2. So you see, the binding energy of reactants, binding energy of reactants equals to A1 E1 plus A2 E2, because that was per nucleon. E1 was per nucleon, so total number of nucleons is what? A1. So A1 E1 plus E2, A2 E2. and binding energy of products is equal to A1 plus A2 into A1 plus A2 into E3. And the value of E3 you see is more. The value of E3 is of the value of E3 is more compared to E1 and E2. Means what? The binding energy of product is more. Binding energy per nucleon of the product is more compared to the binding energy per nucleon of the reactants. So this amount will obviously be more. The energy released in a fusion reaction will be energy delta E that will be released will be equal to A1 plus A2 into E3 minus A1 E1 minus A2 A2 is the energy released in a fusion reaction. Is that clear? Students, you need to make the proper calculation in the proper units. Whatever units all these energy per nucleon is given, like mega electron volt, then the energy released will also be in the mega electron volt. And if the answer is in the joules or in any other unit, you need to convert that into that. Right? Now, so the binding energy released in a fission reaction. Now, see in a fission reaction. What happens in this case is the binding energy per nucleon atomic mass is the graph. Now, what will happen here is that one bigger element of atomic mass, say A naught, whose binding energy per nucleon is relatively lesser, it is E naught. This gets converted into two smaller elements, atomic mass A1 and atomic mass A2. So basically the concept is that the binding energy per nucleon of both the products is what? More. A1 and A2. And binding energy per nucleon of this is E1. And binding energy of per nucleon of this is E2. So now the energy released delta E will be equal to A1 E1 plus A2 E2 minus A naught into E naught, where A naught is equal to A1 plus A2. Because this element is breaking into the two A1 and A2. So A naught will be equal to what? A1 plus A2. I think this part is not visible, so I'm writing it again. A naught is equal to A1 plus A2. Is that clear? And this is the energy released. So hope you understood this. These are very important calculations. So remember them, not only for the JEE main April attempt, but also have seen in many JEE Advanced paper also. The question is usually based upon what calculations I have told you just now. So that's all for this session.